The amount of detail that Unknown Worlds has gone into with Subnautica 2 is astounding. From the smallest schoolfish to massive leviathans, this game is filled with biomes and species alien enough to be fascinating, yet grounded enough in real biology to feel believable. Every ecosystem feels handcrafted. Every creature feels like it belongs. And every time I dive into the waters of Proteus, I find something new. The moon of Proteus has been meticulously built by a team that clearly loves what they do. The first Subnautica released back in January of 2018, and for a studio of Unknown Worlds' size at the time, the cultural impact was incredible. From Let's Plays to documentary style content, the game quickly became one of the most beloved survival games ever made, including for me. I bought Subnautica back in 2016, and I've enjoyed every single moment I've spent with this franchise since. It's been amazing to watch these ecosystems continue to grow into one of my favourite franchises ever. I'm now old enough and know enough about the gaming industry to appreciate how much research, effort and passion has gone into every part of these games. You can feel it in every biome and see it in every creature. But before we jump into Subnautica 2, I'd like to take a quick moment to ask you all to like and subscribe if you enjoy it. According to YouTube's analytics, 93% of you who are watching aren't subscribed. It's completely free and it helps me out massively with the YouTube algorithm. Now, welcome to the Moon of Proteus. Subnautica 2 entered development in April of 2022, just a year after the release of Subnautica Below Zero, and only 6 months after Unknown Worlds was acquired by Krafton. That acquisition would later lead to lawsuits between Krafton's CEO and Unknown Worlds regarding a $250 million earnout bonus tied to performance targets. Unknown Worlds would eventually win the settlement in March of 2026. There's already plenty of videos covering the details of that lawsuit, and for this video I want to focus on the game itself, and more importantly, the people who build it. Despite the previous 2 games being developed in Unity, Subnautica 2 is being built using Unreal Engine 5. The game itself launched into early access in May of 2026, selling more than 1 million copies in its first hour and over 4 million copies in its first week. Ben Prunty returned as lead sound designer and composer following his work on Below Zero, while Anthony Gallegos stepped in as design lead. And already, Subnautica 2 feels like something special. Every biome, creature, sound, and animation feels crafted by developers who genuinely care about what they're crafting. And it's apparent from the moment that you gain control of your character outside the life pod in the Coral Gardens. At present, the Coral Gardens consists of 6 major biomes: the Shallows, the Dolerite Spires, the Plateaus, the Graveyard, the Necrolei Hills, and the Lead Zone, each filled with their own unique flora and fauna, each acting as part of a much larger ecosystem. And it all begins in the Shallows. The Shallows sit near the centre of the Coral Gardens. They're immediately recognisable by their enormous coral domes and dense concentrations of marine life. The seafloor is dominated by vast anemone fields and flexible coral growths that almost feel synthetic to touch. But coral isn't the only thing thriving here. The Shallows are filled with fauna that serve as a player's first introduction to the wider ecosystem of Proteus. And while many of these creatures appear harmless at first glance, almost all of them possess unique adaptations that allow them to survive in this crowded and highly competitive environment. One of the most common is the water slug. Small and surprisingly useful, these organisms process salt water into drinkable freshwater, most likely as a byproduct of feeding on the suspended waste particles drifting through the ocean. Internally, they cultivate colonies of freshwater plankton. These plankton use sunlight to produce additional nutrients for the slug, while the excess is stored and helps counteract dehydration caused by salt intake. Water slugs can be found almost everywhere throughout the biome, making them one of the first available survival resources for new colonists. Sharing these waters are enormous schools of moonfish. The Halfmoon variant appears to feed primarily on plankton, drifting through the open water, though they occasionally graze on smaller coral growths. A rigid beak protects a set of intake valves positioned along its torso. These valves draw seawater into the body for feeding, while part of that flow is redirected internally towards the gills for respiration. Moonfish appear to be easily confused. It struggles to distinguish between disturbances caused by external threats and those created by its own movement. It also displays a strong attraction to artificial light sources. Several additional moonfish variants have been observed throughout the region. These include the harvest moon, the blue moon, and the significantly larger wax moon. At present, differences beyond coloration remain unknown, as their PDA entries have yet to be completed. Drifting alongside them are the Geordies. These salpopods do not swim like traditional fish. Instead, they propel themselves by forcing seawater through a central jet, using rhythmic muscular contractions. Their internal feeding channel is lined with stinging cells capable of killing small organisms pulled inside. The Geordie's hardened mouthparts allow it to scrape algae from rock surfaces while also feeding on small crustaceans. They can even tear chunks directly from coral colonies. Everything they consume is distributed into 4 separate digestive pouches located throughout the fins. As the animal moves, the motion itself assists in digestion. Although the Geordie is technically edible, they are described as being rich in metals and waxes, making them potentially deadly if consumed regularly over long periods. Larger creatures patrol this biome as well, and among the most noticeable is the Hammerhead. Despite being a herbivore, the Hammerhead is extremely territorial. Anything entering its territory risks being challenged. Even other hammerheads. Before attacking, the creature carefully aligns itself with its target. Its large pectoral fins spread outwards as it prepares to charge. Once committed, it feeds water into its internal jet, releasing it in a sudden burst, launching itself forward at remarkable speed. During the charge, the hammerhead closes its shell over its central eye, revealing 2 lower motion sensitive eyes to guide the impact. Its massive muscular jaw is used primarily for grazing on sponges, kelp, and tunicates. They can frequently be seen ramming coral domes scattered throughout their territory. The leading theory suggests these repeated impacts help strengthen and harden their enamel shell, protecting their bodies. Scuttling throughout the anemone fields beneath them, however, are the Periscopic Clowncrabs. These crustaceans shelter among the stinging tentacles of local anemones. These anemones provide protection from predators while simultaneously removing parasites from the crab shells. In return, the clowncrabs transport nutrients back to the anemone fields while foraging. Their elongated eye stalks closely mimic the surrounding anemones, a highly effective form of camouflage, and if damaged or bitten off, they regenerate rapidly. In fact, if they become too long, the clowncrabs will trim them themselves to avoid attracting unwanted attention from predators. Though inedible, they appear to be an important component of the local ecosystem. Not everything hiding among the vegetation is as harmless as it appears. The mimic pylon is a perfect example. What first seems to be a plant is actually a highly specialized predator. The mimic pylon possesses 4 appendages capable of generating powerful electric discharges used to kill or stun prey. It prefers to bury itself near cave entrances. Most of its body remains hidden, leaving only its large beak exposed. To complete the illusion, the organism coats the exposed surface in mucus, making it almost indistinguishable from the surrounding plant life. The shallows are also home to vast schools of mirror halfmoons and fluttertails. Perhaps one of the strangest animals found anywhere in the biome is the Foureye. Despite appearing to be a single organism, the Foureye is actually composed of 2 entirely separate animals. They are always born as identical twins. Shortly after birth, the pair joins both their digestive and nervous systems together. This connection is created through an embryonic yolk stalk that grows between them, allowing them to share nutrients and brain function. This result is a pair of organisms capable at swimming and maneuvering in complete unison. The Foureye is highly aggressive and will attack larger organisms if provoked. Despite their dependence on one another, the twins retain the ability to separate. Once sexually mature, they disconnect and search for suitable partners of the opposite sex. After locating one, they reconnect to form an entirely new Foureye pair. Pairs unable to locate an opposite sex partner may temporarily join with members of the same sex while continuing their search. The deeper cave systems within the shallows reward exploration, but they also come with inherent risks. The obvious threat is suffocation, but the caves contain far more hazards than simply running out of oxygen. Many cave entrances are lined with toxic sponges. These organisms release compounds capable of causing severe skin and nerve damage. Painful to humans, fatal to smaller fauna. Further inside the cave systems lurks another threat, the Sandspear. This ambush predator burrows beneath the sand and waits patiently for prey to approach. Its jaw remains locked backwards under tension. When triggered, they snap shut at speeds approaching 20 meters per second, delivering enough force to penetrate armor and startle unprepared explorers. Within these cave systems also lives our first species of Raion, the acid Raion. These organisms contain the acidic compounds required for the fabrication of functional batteries. Despite its appearance, the acid Raion is not a plant. Instead, it's a sponge inhabited by colonies of predatory worms. Internal chambers within the sponge separate and process waste materials, and the worms themselves secrete powerful acidic compounds used to digest prey. Any excess acid is redirected towards a central pumping organ, and when the Raion is threatened, it will eject this acid as a defensive weapon. Far more important to early survival are the oxygen tunics. Before players gain access to larger oxygen canisters, these organisms provide an invaluable backup supply of air. At first glance, the oxygen tunic resembles a plant. Scans, however, show otherwise. This organism possesses both a nervous system and a functioning heart. Its internal structures contains radioactive materials capable of splitting water molecules into hydrogen and oxygen. The oxygen is then released as a byproduct. The Coral Gardens begins guiding players away from the safety of the shallows and towards the wider world beyond. The angel combs growing throughout the region naturally direct explorers northward, towards the plateaus and the Anemone Hills. These neighbouring biomes introduce an entirely new ecosystem, abandoned survivor bases, and wreckage from the cicada. They start to reveal the first few clues about what happened to the other colonists stranded on Proteus. They also introduce something else: predators. Guarding the outskirts of these regions are the Nibbler Mangos. These omnivores travel in groups both for hunting and for protection against larger carnivores. They are opportunistic feeders, willing to consume almost anything their powerful jaws can crush. Those jaws possess enough force to break apart dead coral, and even human bones. Much like the sharks on Earth, the Nibbler Mango constantly replaces damaged teeth. Hundreds of replacements wait beneath the surface, ready to move forward whenever needed. The Nibbler Mango is one of the ecosystem's most important recyclers, though unfortunately for you, humans are also considered a possible food source. Beyond these hunting grounds, the seafloor begins to change, the coral domes disappear, the landscape rises, and the player enters the plateaus. The foundations of the plateaus are built upon countless generations of coral polyps. Over immense spans of time, these colonies lived, died, and compressed into thick layers of limestone. New colonies continue growing above them, slowly pushing the entire landscape upwards towards the surface. Resting upon many of these plateaus is the Behemoth finger-legged jelly, or the BFJ. Most of the creature consists of an enormous gas-filled bladder. By flooding this bladder with seawater, the BFJ can sink and rest directly on the seafloor. Positioned atop the jelly are clusters of sensory organs known as Repalia. These structures contain both eyes and gravity sensing organs capable of functioning in both seawater and open air, hinting at this creature spending some time above the waves in its future life cycle. Its enormous arms are formed from powerful muscular tendrils covered in sensory hairs. These hairs allow the creature to detect mineral traces within the seafloor. Despite its immense size, the BFJ appears to feed primarily on sunlight, spending years preserving energy before transitioning into a later form. The nutrient-rich limestones of the plateaus supports a staggering diversity of life: corals, tunicates, sponges, and countless species still waiting to be fully documented. Among these is the Cherimoya Rotsac. This tunicate survives by converting alcohol produced by surrounding decay into a creamy edible mucus. Reproductive cells are mixed directly into its sugar deposits, and when consumed by another organism, these cells enter the digestive tract of the host. They are fertilized before eventually being expelled. The Lucifer Rotsac acts as a biological opposite to the Cherimoya. It instead ferments decomposing biomatter into alcohol. Hidden throughout the shadows of the plateaus are colonies of Jellylae. These organisms represent the rooted polyp stage within a jellyfish life cycle. The petal-like structures extending from their stems are actually juvenile jellyfish. Each one represents an underdeveloped adult waiting to reach maturity. Living among the sponge colonies is another unusual member of the Raion family, the Raion donut. Like the acid Raion, this organism is a sponge inhabited by colonies of predatory worms. These worms extend outward through the sponge's gelatinous tissues, using their stinging appendages to capture prey before dragging it back inside their colony. The plateaus may appear peaceful from a distance, but the sheer biodiversity found here inevitably attracts predators, and few are more dangerous than the Marrowbreach. This massive shark-like carnivore possesses jaws lined with razor-sharp fragments of iron and salt, capable of delivering thousands of newtons of force in less than 1/6 of a second. Its eyes are connected directly to the jaw itself, reducing reaction time between detection and attack. The creature's skin is coated in a jelly-like sensory layer capable of detecting both vibrations and electrical fields within the surrounding water. Combined with highly sensitive hearing, this allows the Marrowbreach to locate prey long before the prey becomes aware of it. Before attacking, individuals will often circle their target, sometimes even lightly bumping it, assessing if it is a threat. Then, without warning, they accelerate forward using their enormous rear fins in a sudden burst of speed. The result is one of the most intimidating predators currently found within the Coral Gardens. Yet, even below the hunting grounds of the Marrowbreach, another ecosystem waits. Hidden below the limestone itself, an enormous cave network stretches beneath the plateaus. Its tunnels illuminated by the glow of the cabbage shootroot. Found throughout these spaces are organisms known as the Dangling Salps. These colonies begin as groups of genetically identical tunicates attached to the cave ceiling. As they mature, they grow long tube-like pumps extending into the water below. Using these structures, they continuously draw seawater upward through the colony. Plankton and suspended nutrients are filtered from the passing currents before the remaining water is expelled. But while the plateaus have some of the more unusual life on Proteus, the neighbouring biome has some of the most colourful, as it's filled with a forest of rooted jellyfish stretching across the seafloor. Fields of purple life stretch across the seabed beneath towering jelly-like structures swaying with the current. But beneath all the beauty lies evidence of a much larger ecological problem. The dominant life form of the biome is the Necrolei. These organisms are not plants, nor are they single animals. Instead, each structure consists of enormous groups of biologically identical jellyfish, permanently rooted to the substrate rather than drifting through the open ocean. The Necrolei feed by filtering organic matter from the surrounding seawater, specifically dead organic matter, and the sheer size of them suggests there is an enormous amount of death and decay occurring somewhere else on the surface of Proteus, enough that the currents are transporting a constant supply of nutrients into this biome. The Necrolei themselves appear specifically adapted to survive within low oxygen environments. Rather than immediately digesting their food, they ferment it within a central basket. This process produces large quantities of acidic waste products. The excess acid is deposited around the Necrolei's eggs, creating a protective barrier capable of discouraging predators and preventing infection. The eggs themselves appear to possess a relationship with the nearby silt orbs. Exactly how this relationship functions remains unclear. The PDA entries for the silt orbs have not yet been completed. However, the cysts found upon their surfaces can be harvested and processed into extremely powerful acids. Among the Necrolei lives a colony of Periscopic Clowncrabs. Unlike their relatives found within the shallows, these individuals have altered their coloration to match the purple environment surrounding them, allowing them to disappear almost entirely among the anemones and jelly colonies. Occasionally, however, something much larger appears over the forest canopy. The Hycean. Named after planets made up of both ocean and hydrogen, the Hycean is one of the only currently known airborne organisms on Proteus. The entire organism is filled with hydrogen, allowing it to fly up above the surface of the sea. This hydrogen is produced through a remarkable relationship with a bacterial symbiote. This bacteria converts ammonia into carbon nitride. When exposed directly to sunlight, the carbon nitride splits water molecules and stores the resulting hydrogen for flight. This comes with an intense drawback, however. Hydrogen is highly flammable. Whenever storms approach, Hyceans retreat beneath the surface to avoid the risk of lightning. Large rear fins assist the creature with steering while airborne and maintaining stability in high winds. The PDA suggests the Hycean might represent the final stage of the Behemoth finger-legged jelly. Found on the outskirts of this biome is the Hecaton Tunic. Each structure consists of hundreds of individual tunics living as a single colony. Every pore across its surface contains a functioning mouth. The colony begins its life as a single stem, duplicating itself over time. The most successful members become primary reproductive bodies, while the weaker individuals are pushed outwards towards the colony's extremities. What makes this tunic particularly concerning is it has no way of reproducing without being heavily infected by an ocean-borne pathogen. Because not too far from this tunic, we are finally introduced to one of the greatest threats currently on Proteus. A pathogen that has begun reshaping entire ecosystems, officially known as Proteavirus. The nearby blighted coral has been overwhelmed by a variant of this virus called Bloom, Proteavirus beta. Growths spread across the landscape, wildlife behaves differently, and progression further into the region is impossible until the infection is dealt with. Bloom is a variant of a virus that has been manipulating the very environment and biology of everything we have spoken about. Its spread appears closely tied to the enormous organisms known as the Titan rock boars. These massive structures are everywhere throughout the region, and angel combs grow from them. Current evidence suggests the rock boars are actively replicating the virus, while the angel comb serves as a distribution network. When Proteavirus infects its host, it appears capable of altering them. The pathogen can transform the cells of one's organism into those of another, as though it's collecting biological information from every species it encounters, then rewriting life itself to better suit its own needs. By all conventional biological understanding, this should be impossible. Yet, throughout Proteus, evidence suggests it's happening regardless. Reusing biological structures and accelerating evolutionary change at a pace that should never be possible. But somewhere during this process, something changed. A second strain emerged, a mutation, and a competitor, Proteavirus beta, more commonly known as Bloom. It infects nearby organisms with a singular purpose: reproduction. Bloom establishes large reproductive sites known as bloom nodes around juvenile angel combs. It then uses the comb's own biological systems to mass produce the virus. These sites are typically surrounded by 3 or 4 structures known as bloom cankers. The cankers act as storage organs, accumulating solid crystalline deposits of the virus before releasing it back into the surrounding seawater. Once released, the virus feeds by absorbing nutrients from microorganisms killed during the infection process. Bloom appears locked in direct competition with the original Proteavirus strain. Destroying the bloom cankers weakens the beta strain enough for the original variant to regain dominance. But the bloom infection is not completely defenseless. Protecting these nodes are organisms known as bloom parasites. These squid-like creatures actively seek out larger prey. Lacking eyes, they rely primarily on scent. Once a suitable host is found, the parasite uses its beak to cut an incision into the victim. It then inserts an elongated tongue and begins feeding. The parasite remains attached until removed or fully fed. While feeding, it performs another task: transmission. The bloom virus is passed directly into the host organism. Infected creatures become highly aggressive, highly territorial, and intensely protective of nearby bloom cankers. Once the bloom infection surrounding the angel comb is cleared, players are able to progress further into the coral gardens, beyond the infected reefs, beyond the safety of the shallower waters, and towards a warmer region known as the graveyard. But before heading deeper into the main progression path, there are still two neighbouring regions worth exploring: the Tufa Towers and the Lead Zone. The Tufa Towers is a relatively small sub-biome located to the south. They are immediately recognisable by the massive stone towers rising from the sea floor. These formations give the biome both its appearance and its name, but the towers themselves are not the region's most impressive feature. That honour belongs to its resident Leviathan, the Greatjaw. The particular Greatjaw currently inhabiting this biome appears to be relatively young. Much like the clams of Earth, the organism consists of two enormous shells connected by a powerful central muscle. Whenever sensitive tendons within the structure are disturbed, the jaw starts to close. Once closed, the Greatjaw fills its internal chamber with a noxious gas. This gas kills trapped organisms before digestion begins. Despite this predatory behaviour, evidence suggests prey capture may not be its primary food source. The interior mantle is lined with motion-sensitive eyes, alongside tiny coral polyps. These polyps feed on sunlight, indicating that a significant portion of the Greatjaw's energy may come from photosynthesis rather than hunting. As the organism grows, it continuously excretes lithium. This appears to be a biological adaptation designed to prevent dangerous mineral accumulation within its nervous system. The presence of only a single Greatjaw raises interesting questions. It may represent the last survivor of a once thriving local population, a remnant of an ecosystem that has already collapsed, or alternatively, there may be a larger colony hidden somewhere else on Proteus. Evidence suggesting additional Greatjaws exist has already been found within a region known as the Sparse Plains Trench. But for now, however, this solitary Leviathan remains the undisputed ruler of the Tufa Towers. Around it float vast swarms of bioluminescent jelly, known as the Surge Jelly. Its outer bell is surrounded by sensory structures called Ropalia, similar to those seen on the BFJ. The translucent outer layer of the organism allows many of its internal organs to be observed directly through its bell. Beneath the jelly hangs a stalk-like structure, likely a remnant from an earlier stage of its life cycle. This stalk connects two rigid fins that closely resemble those found in electric eels and ray species. These fins contain electrocytes, capable of generating powerful electric discharges. The voltage produced appears sufficient to stun or potentially shut down the nervous system of an average human. Very little is currently known about the Surge Jelly's reproduction. However, it most likely reproduces in a similar manner to the Jelly-lay. It is even possible that the Surge Jelly itself is the mature adult stage of that organism's life cycle. Compared to the surrounding biomes, the Lead Zone is remarkably barren. The small atoll is dominated almost entirely by large deposits of lead. At present, very little life has been documented here. The only exception is the occasional Deepwing Brooder passing through the area. The Deepwing Brooder is the second Leviathan-class species we have encountered so far. These enormous creatures are migratory and are frequently observed patrolling the outskirts of multiple regions throughout the Coral Gardens. Despite their intimidating appearance, much of their anatomy suggests a filter-feeding lifestyle. The Deepwing Brooder's throat is lined with specialized structures used to trap plankton, while filtered seawater exits through the gill openings located in the rear of its keel. Yet its enormous beak appears perfectly adapted for cracking, tearing, and crushing. This suggests the brooder may also be opportunistic in its feeding. Potential prey could include the nutrient-rich fluids of the Titan rock boars and the shells of Greatjaws. Layers of oil accumulate beneath its outer shell. When it becomes time to reproduce, They release this oil alongside their eggs in the form of countless droplets. These droplets act as decoys, drawing the attention of predators away from their true offspring. This also has the added benefit of fertilizing the biomes beneath with hundreds of concentrated nutrients. The absence of most life makes the lead zone one of the strangest regions within the Coral Gardens. Surrounded by some of the most biodiverse ecosystems on the moon, yet seemingly unable to support an ecosystem of its own. Whether this is due to the excess amount of lead in the biome or for other environmental factors is unknown. The North and South Raceways are vast stretches of open ocean. Compared to the dense ecosystems of the Coral Gardens, these regions feel almost barren, but they're home to one particularly remarkable inhabitant: the coral crab. The coral crab is a Leviathan-class crustacean. These creatures have learnt to cut entire coral domes free from the seafloor and wear them as both armor and camouflage. At a distance, what appears to be just another section of reef may in fact be a moving Leviathan. They march slowly across the seabed using their two enormous frontal limbs to dig into the sand and expose buried food sources. As they move, sediment is overturned and nutrients are brought to the surface, feeding countless smaller organisms in their wake. The coral crab possesses an unusually complex nervous system. Its large primary brain is responsible for processing sensory information and behavior, while the secondary nerve cluster manages both locomotion and digestion. Current observations suggest they may possess the intelligence comparable to that of a gorilla. Their massive frontal limbs serve another purpose as well: communication. By striking the sea floor, coral crabs produce powerful drumming signals that travel through the substrate. These signals appear to be used as warnings or to convey excitement. Despite being so large, they are currently the smallest organism within the entire Subnautica universe to be officially classified as a Leviathan. Yet, while they thrive through the North Raceway, the South Raceway tells a very different story. The seafloor here is littered with the remains of an entire coral crab colony. Carcasses stretch across this region. What caused their deaths remains unknown. It may have been Proteavirus beta, it may be the result of an ecosystem already in collapse, or perhaps something far larger was responsible. Something powerful enough to wipe out an entire colony of Leviathan-class organisms. For now, there's no answers. And past these raceways lays the last major biome in the Coral Garden region: the graveyard. This biome is dominated by hydrothermal activity. Thermal vents cover the seafloor, raising the ambient temperature to almost 85 degrees Celsius. It is an environment that should be hostile to most forms of life. Yet, for some species, the heat is exactly what allows them to thrive. Among the hydrothermal vents are vast colonies of jelly rings. These organisms settle around the active vents like wheels mounted upon an axle. As long as the vent remains active, the colony remains anchored in place. Once the vent eventually dies, the jelly ring simply moves on. It uses its own body as a swimming structure to migrate towards new heat sources, composed of thousands of tiny animals known as zooids. Unlike the previously mentioned tunicates, the flower-like formations surrounding the ring are pumps that draw both seawater and hydrothermal vent fluids through the colony. They distribute nutrients and regulate temperature. They can even reverse their direction to function as swimming thrusters when relocation becomes necessary. Not every species in the graveyard relies directly on the vents themselves. Some instead take advantage of the biome's apex predators. One such example is the Houndgar. At first glance, the Houndgar appears to be an ideal prey for the Marrowbreach, yet rather than being hunted by them, the two species appear to hunt together. The Houndgar flushes prey from hiding places, and then performs a display that distracts and marks the target. This compensates for the Marrowbreach's poor vision, and allows them to find their target with ease. Once the Marrowbreach is fed, the Houndgar will feed on whatever scraps are left behind. The vast tunnels beneath the surface of the graveyard are even stranger. Down here lives an organism that looks like a stack of clams balanced atop one another. very little is currently known about this species. Not because it's particularly rare, but because the PDA itself appears to have conniptions whenever it attempts to analyze it. At present, these organisms are simply referred to as hi-hats. Beyond their ability to survive within extreme temperatures, almost nothing has been confirmed about their biology. For now, they remain one of the many unanswered questions lurking beneath the waters of Proteus. A small village sits hidden among the cliffs surrounding the entrance to the graveyard's subterranean cave system. Dozens of small huts cling to the rocky walls overlooking the biome below. Many remain unfinished, and apart from the prowling Marrowbreach, no life is anywhere to be seen. This is our first sign of the Axiom on Proteus, but we'll learn more about them when we explore the region known as the Cricorum. For now, one final obstacle still awaits us, because lurking the border between the Coral Gardens and the Cricorum is a Leviathan that hunts other Leviathans. Above all other predators currently documented on Proteus, one species stands apart: the Collector Leviathan. A Leviathan whose anatomy suggests not only immense strength, but an equally dangerous level of intelligence. At first glance, the Collector is remarkably similar to that of the Earth's squid. A long mantle forms the bulk of its body, while numerous limbs extend directly from its head. The mantle is protected by layers of armor, giving the creature an appearance unlike anything else we've seen so far. Unlike the Earth's squid, however, the Collector possesses 4 elongated hunting tentacles, extending in a highly dexterous claw. Its remaining 8 arms are considerably smaller and clustered around a massive central beak. Powering this enormous predator is a highly specialized propulsion system. 2 large spiracles feed a powerful rear-facing thruster, capable of driving the creature through the water at high speed. These spiracles are entirely separate from the 4 gill openings located around its head. This allows the Collector to regulate breathing independently from its movement. 2 secondary hearts pump blood from the gills back towards the primary heart, ensuring sufficient circulation during periods of intense activity. Every aspect of the Collector's anatomy suggests a predator adapted for overcoming heavily armored prey. Its enormous beak is reportedly capable of tearing through plate titanium. Meanwhile, the 4 hunting tentacles are equipped with razor-sharp claws. Together, they create a set of tools perfectly suited for prying apart protective shells and dismantling prey that would be inaccessible to most other predators. Potential prey species include coral crabs and even greatjaws. A more unusual structure within the animal is a massive organ positioned around the head. Known as the broadcast organ, it functions as a biological sonar. Multiple chambers act as both speakers and receivers, allowing the Collector to generate highly complex, multi-part sonar pulses. Altogether, the evidence paints a picture of a predator unlike any other currently known on the Moon. It's capable of dismantling armored prey, capable of curiosity. Although this Collector has likely wandered a little far away from home. This small trench is only a section of what is to be the sparse reef, the home of the Collector Leviathan, which will come in a further Subnautica 2 update and in a further video.